Okay, so this is a gear, this is another gear, right?
Okay.
And the way they work, and these are called teeth. Okay, and the number of teeth in these two gears are exactly same at the same time. So when we put them together, it changes the direction, right? One causes the other one to move. So you can use gears to change the direction. But apart from changing the direction, what else it is doing? It's doing one other thing. It's moving the center of axis from here to here, right? Right? Center of axis has changed as a result of this. At least the speed is same, the rotation is same. If you want to change your rotation, you can use gear of a different size. Okay? And the difference between these two teeth, the ratio of them is called the gear ratio. Okay? Let's assume this one has about 50 teeth. I don't know how many it is. Let's assume approximately. How many it is? 36. And how many this one has?
I think it's, no, I don't know.
14.
24. One is 36, 24 and 12.
Okay.
Yeah.
So
That's
this is
24.
24, this is 36, right? So when you put them together and they have to rotate, let me see, let me put it here. And let me move this one over here. Okay? Now if I rotate this one, what happens?
Rotate.
So when I'm rotating the small one, in the full rotation it is moving how many steps? 24. This one has 36, so it will not rotate full 360 degrees, right? So this one will not be able to rotate full 360 degree. But if I rotate this 3 times, this one will rotate 2 times. Right? How much is 24 times 3? Who wants to say? 72. And this is 36, 2 is 72. Right? So 3 rotations of this is same as 2 rotations of the bigger gear. Okay? And I can change this, and I can use the smaller gear, just 12 teeth, then what will we get? A ratio of 1:3,
Oh, yeah.
12 and 36, right? Okay?
So what would be more accurate if you spin the larger one with the motor, or would it be accurate if you spin the smaller one?
Actually, it really depends what you're trying to do. Okay? If you use a motor with a large one, okay, and you want to use a small one, it is multiplying. Because one rotation of this is giving you 3 rotations of this. Okay? So if this one rotation has a problem of by 1 degrees, you will get 3 degrees problem. Because 360 degrees of this is 3 times 360 degrees of this, because in one rotation of the big one, we are getting 3 rotations of the small one. If you put motor on the small one, you can make 3 rotations of this and only make 1 rotation of this. Right? So even if the error is by 3 degrees, this one will only see an error of 1 degree. Okay? But will slow down. It will slow down the job. Right? The motor has to take more time to make 3 turns, and then you get 1 turn. So it will slow down the job. But you can do heavy stuff. If you want to lift heavy stuff, you can take 3 rotations, you get 1 rotation, but you will be able to lift 3 times more heavy stuff. Okay? You get the torque. How many you know about torque? You know torque?
No.
Okay. Let's just
I
skip.
heard it was familiar before.
Torque is how much angular force. Let me just say that. Okay. You know the simple force? It's some sort of angular force. Think of that. Okay? Okay? So this is all about the gear ratios. Now, what else? I can put this gear in this direction and still rotate. can change the axis too. Right? You can change the axis. And we have two examples of it right in front of our eyes. Can you locate
This one.
this one? Yes. There's one more example right in front of our eyes.
Mine.
That one.
Over there.
There are a lot of talent.
So again here we have two different gear ratios, right? One smaller gear and one bigger gear. Motor rotates and then this one rotates accordingly. Okay. Instead of this being this one, we have a bigger one, even bigger one in this one over here, if you can see.
Oh, I see.
Okay. For the camera, here it is. So we have a small gear here and a bigger gear here. Okay. So what happens when a small motor is rotating the bigger one? What happens? Motor has to rotate 3, 4, 5, 6 tons. I don't know how many. Let's assume it's still the 12 to 36. It's 3 tons. So you get more accuracy of this one, right? How much forward and backward. Okay. It doesn't need enough force. So even though this can provide more force, more torque, that's not the problem. It gives you the more accuracy. Okay? So this gear is rotating this gear and this gear is then rotating this color sensor forward. Okay? So it just moves the color sensor forward. Other thing it is doing is the circular motion is moving this into a linear motion. The motion sensor is pretty much, the color sensor is coming forward and backward. Okay? That is exactly what we have in this small example here, right? This one, so color sensor forward, color sensor backward, color sensor forward, color sensor.
Train works, the train.
Yeah, this is exactly how the train engine works. In train engine, what happens? You're burning something, let's say it's a diesel train engine. What happens? Diesel will burn, it will push the piston up, then it blasts, and this is the piston. So it will come back and then move forward. And as a result, it will create a circular motion. Okay? And then you have it either through a chain or through other gears, you take that and move to the next wheel, right? So one of the problems with the gears sometimes is they need to be touching properly, and if they are not, then what happens?
Then one gear will stay still and the other one will just keep.
Yeah. So if I have to use these two gears, let me just show you. And I just want them to be there linearly certain distance apart. We have only limited set of gears here, right? We cannot design these of any size. So what happens? There's a gap. Let me move one step forward. Is it touching?
No.
No. Next back, what happens? It's overlapping. It's too big. Here we have a gap.
And use a
See that?
smaller gear.
But I need exact same gear ratio. Then what do?
Use a smaller gear and then a bigger gear.
Yeah, I could do that, but then the rotation will be different.
You could put
The
them
angle will change. Suppose I move this one and put this one back. Now what happens? The rotation direction of this and this is same.
Then I have two smaller ones.
So now I still have a problem, right? So gears are not easy to work with. There's a lot of things that can go wrong. Okay? Other things that can happen is they can slip.
Oh yeah.
Okay? If you don't have the proper fitting between them, then they can cause some sort of slipping. Okay? And the gears can break. If one of the teeth breaks, what happens?
Then you get the whole thing.
Then it can cause a problem for the whole assembly, right? Then we use chain. Okay? With chain, how many of you ride bikes? Everybody. And whose bike doesn't have gears? Your bike doesn't have gears, but it has chain, right? It does have chain. Yeah. It has just have gear. I'll tell you. I'll tell you. See, this one is okay, because I was able to adjust the angle. Okay, but then this is just a rotation. I need to somehow make it rigid. Right? Yeah. So we'll have to put something which fits exactly, and we may not be able to find again then the holes which align. Okay. So then we use chain. That's why your bikes, especially when you have a gears, the chain, it has a spring to keep the tension, and then the chain rotates around. Okay. And even when your bike has a chain, but you think there are no gears, the gears are different size. You pedal it different gear size, and your tire is on a different gear size. There's a chain combining these two. Okay. A chain just helps to, as if the two gears are touching each other.
But
Okay.
Lego doesn't make any chains. That's basically useless.
What are you saying?
Lego doesn't make any
It does.
chains.
It does.
It
It
does?
does. It does. And you have it.
Oh yeah.
You the caterpillar
Caterpillar
chap?
In fact, the
Caterpillar tracks?
the caterpillar wheels that you were talking about earlier, it's effectively a rubber,
I want
effectively like a chain.
Yeah, it's so
It does work on these.
Yeah, it does.
It does. Actually, you use these on. You put these, and then you put.
comes with it.
Oh yeah.
Okay. So you got different types of. So you now know what is the problem with gears.
No, but the track is a
They
seven
need to
cell.
fit exactly. They need a butt. Okay, but if you are making them which makes them not abut properly, then you have a slip. Okay. Now this is another type of gear. Okay. Earlier we talked about changing the direction, right? And we have two gears. What happens in this case? The axis is changed. Okay. Rotation in this axis has changed to a rotation on this axis. Okay. Now this is another way of changing it to a linear.
Oh yeah, what is that called?
Okay.
Worm gear.
Yeah. So this one, if we this rod. Okay. Then what happens? No, this one doesn't slip. No. Okay. So the advantage of this is you can move, I would say advantage and disadvantage. You can move force from one direction to another, but not the other way around. So when we had these two gears, I could put motor on one of them and use the force on the other side, right? I could put motor here, or I could put motor here. Okay? I could put motor here, I could put motor here. With this worm gear, what happens is if I put a motor on this one and want this to move, it will not move, because what will happen? It will slip. The force direction is so much on this, it will not be able to rotate. Okay? But if I use my motor on this one, okay, and my motor is rotating, so then this amount is about 2 millimeters or 3 millimeters, right? So every rotation is only moving this wheel by 2-3 millimeters. So the gear ratio suddenly changed a lot. Okay? So as if one rotation of this is like one teeth rotation of this. So it's like 36 times. Right? So you can actually lift a lot of weight 36 times. Okay?
How do you lift weight using gears?
You can put a thread or something which is lifting, and the thread will. Okay? So this can change your angular rotation into rotation from this axis to this other axis, and provide you with a lot of force. Okay? You have to multiply a lot of force, that's when you use this. Okay? it?
Yeah.
Any questions on the worm gear? So now you know about gear ratios,
Worm gears.
worm gears,
Angular.
angular motion. You know about torque. And one other thing, if you have 3 gears and they're touching each other, it creates a jam.
You did this last.
Did that last year? If I take this and this, and if I have this gear touching all 3, then what happens? It creates a jam. Because this one is trying to rotate, these two are not rotating in the same direction, right?
No, but if they are rotating in the opposite direction, it's very slow.
Yeah, but only the abutting ones are rotating in the opposite direction. But if you touch these two, then they are in the same direction. So what happens as a result?
Skids and jam.
You break the motor.
So it can break the teeth, it can break the motor, it can burn the motor.
How about
Ah.
this gear?
So this one is specifically designed to be at the 90 degrees. So even we can do that with these 2 gears also. I can put this like this. Right?
Yeah, but I think it's more better with the other one.
Yeah. So even this can be used at 90 degrees, and they have made this one special, just for the 90 degrees. Okay, but this is very much same as these gears, except that they have made it thinner.
Yeah.
Okay. So this can be used, it just provides a different gear ratio.
Yeah.
Okay. Any other questions?